Number 78. When a person sits erect, increasing the vertical position of their brain by 36 centimeters, the heart must continue to pump blood to the brain at the same rate. Letter A. What is the gain in gravitational potential energy for 100 milliliters of blood raised 36 centimeters? All right, so for letter A, they're simply asking us to calculate gravitational potential energy. Let's start with the formula, right? So the gravitational potential energy is simply the mass of the object multiplied by gravity, then multiplied by the height to which that object is raised. So here's our little picture. There's 100 milliliters of blood. Remember, this volume has a certain mass to it. And this volume of blood is going to be raised by 36 centimeters to now this location. All right, so the gravitational potential energy has gone up because the ending height is higher than the initial height. Okay, right? I could really kind of substitute in delta H here for height if I wanted, right? Where it's the final minus the initial. So in calculating this, right, we basically know everything except for the mass, right? We do know the volume, and we probably need to know, or it should be given to us, or you'll be provided it. We need to know the density of the blood in order to figure out the mass, right? So I basically need this equation to relate mass. That's volume, right? To relate volume to mass, you need to know the density. Namely, to know the mass, you need to take the density and multiply it by the volume. So what I'm going to do here is I'm going to substitute this on into my equation. So we have the gravitational potential energy being equal to the density of the blood multiplied by the volume of the blood times gravity times then the height it was raised to. So the potential energy of gravity, we need everything in standard units. All right, so the density of the blood is going to be 1,050 kilogram per cubic meter. The volume, they gave it to us in milliliters, but we need that in liters. So divide by 1,000 or simply just move the decimal place 3 places to the left. So it's 0.100 liters. And what am I doing? Right, this has to be in cubic meters. I was just seeing if you were paying attention, right? That's all. Just seeing if you were paying attention. This has to be in cubic meters. So I don't remember that off the top of my head. So let's just do the quick conversion over here. So it's going to be 100 milliliters. First thing I will do is convert that into, So first thing I will do is convert that into cubic centimeters. So milliliter on the bottom, centimeter on the top, cubic centimeter, right? This is the definition of a cubic centimeter. It's 1 milliliter. So that takes care of the milliliters. They go bye-bye. And now I'm left with centimeter cubed. And now I can go from centimeter to meter. All right, there's 100 centimeters in 1 meter. But I got to cube this result, so I cancel the cube centimeters there. All right. So this essentially now, when I plug in the volume, all right, it's going to be 100 divided by 100 cubed. All right, or just 1 divided by 100 squared. Doesn't matter to me what you do. So multiply that then by gravity, 9.8, and then multiply this by the change in height, 36 centimeters, but we need that in terms of meters, so just move the decimal 2 places to the left. You're basically dividing by 100, 36. Okay, so now we can calculate the potential energy, the gravitational potential energy. Remember, this will be in joules now. So 1,050 times 100 divided by 100 cubed, then times 9.8 times 0.36. So here we get a value of now about 0.370 joules, right? So that will be the change in potential energy of that amount of blood. All right, let's take a look now at letter B. So letter B, what is the drop in pressure, neglecting any losses due to friction? All right, so now we're talking about pressure, okay? And if you notice the nature of this, right? What about this fluid in here, the blood that is changing? Well, the only thing that's changing is the height, right? So I'm actually going to be using this formula over here on the right-hand side. So the pressure will be equal to the change in height, essentially, or the height differential, multiplied by the density of that fluid, which we're talking about blood here, multiplied by gravity. Now the thing is here, what should the height be? Should it be positive or negative? All right, that's the question. So if you think about this, this is kind of the reverse of all these height problems we're used to dealing with, right? If you have a column of fluid here, okay, we're used to saying that the height, you're starting at the top, right? This is your initial height, okay? And then this is your final height, right? Essentially. Where you're trying to find the pressure at the bottom of this column, okay? And we've always been plugging in positive values, right, for the height here, okay? In this problem, it's exactly reversed, right? We're not ending at the bottom this time, we're ending at the top. So since it's the reverse, a simple explanation here is that it will be negative, okay? That the height of this thing is going to be now a negative value, and therefore should be causing a decrease in pressure, and that's kind of what they're telling us it should be anyway. It's right, it's saying drop in pressure. What is the drop in pressure? Now you can answer this as a negative value, or you can answer it, I mean, technically it should be negative, but if they're saying what is the drop in pressure, you probably could phrase it as a positive since they're asking what's the drop, and you can tell them the magnitude of it. But anyway, I'm just going to plug in the negative here, right? So here we have the height. It is negative 0.360 multiplied by then the density of blood, right? So that's going to be, again, the same value, 1050, multiplied then by gravity of 9.8. And here we now have the pressure becoming, it's a drop, it's going to be negative, 0.36 times 1050 times 9.8. And here we have now, what do we have? 30, so 3.70 times 10 to the third, right? Or about 3,700 pascals. All right, will be it will be reduced by. Okay, so let's write that. Let's box that answer. All right, guys, thanks so much for tuning in. Appreciate it very much. Please remember to subscribe, and we'll see you next time. Take care.